Okay, so good morning, pre-calc. We're going to do 5.3 semester 2 Apex. So we're going to start talking about vectors. So a lot of quantities that we deal with in math, geometry figures, or physics, chemistry are just numbers, just single numbers. But other quantities like force and velocity actually have both magnitude and direction, and they can't be characterized by a single number. So we have to use what's called a vector. So a vector is a directed line segment. In other words, it's a ray. It has a starting point, okay, and it goes on forever in one direction as a ray. Okay. Now, the vector actually has an initial point and it has a terminal point going in a certain direction, but it actually stops. Okay, so it's kind of like a ray that stops, or like a flashlight, or a, one of those red pointer light beams. If I shine that in a direction and then I put my hand in front of it, it stops. Okay, so that would be the vector. It would have a direction and it would have a certain length or magnitude. Okay, so the magnitude or length is these little double absolute value sign is what it looks like, and then it's around the vector name, or in this case, the 2 points that create that vector. Sometimes on worksheets and stuff, you'll see it as just a single line, but you have to know the difference between absolute value and magnitude. Really, magnitude or length is a distance, so it is going to be the absolute value, but you have to do a little bit of work to it first, and we're going to talk about that as we progress. So a directed segment that has the same magnitude and direction are called equivalent. And all equivalent directed line segments are represented by a vector V in the plane. Okay? And it's written as, so we would have V equals, and here we would have V1, a V2 essentially. Okay? Or there are X and our Y coordinates. Okay, so we're going to be using sine, cosine, tangent for these. The same as we would any type of line, okay, or ray or segment, because vectors are just that. They're essentially a line segment. The only difference is they're going in a specific direction. Okay, so essentially for V equals PQ, okay, our vector would be, let's see, it's going to be our x2 minus x1 and our y2 minus our y1. So we're going to find it just by finding, the x component and the y component. Okay. Common vectors are lowercase bold letters. So remember that lines can be denoted by a lowercase letter. Vectors are denoted by a lowercase bold letter. Usually, in math especially, we know when we're talking about vectors and we're writing in pen and pencil, so we're not going to be actually bolding it, okay? But we will be using it. All right, so let's go on ahead and look at an example. So this is just an easy example, when we might use vectors. So it says, suppose a bird is flying north at 8 miles per hour. Okay, so my bird is flying north. My velocity is my actual length or my vector. Okay, it is my length or my magnitude. Okay, so the coordinate of the vector, V bird, oh, that was, that was my bird. So V bird, the coordinates are 0 because it's left and right 0, up 8. So that's where it stops. Okay, so terminal point minus initial point. Its magnitude is 8. Okay, magnitude is just the distance formula. Okay, so it's going to be x2 minus x1 squared plus y2 minus y1 squared. In this case, 8 squared plus 0 squared is 64. Okay, square root of that is just 8. Okay, so it's really easy when you have it just going vertical or horizontal. Okay, but we're going to get into ones that are not going vertical or horizontal. Okay, it says next that the wind is blowing from the west at 4 miles per hour. So keep in mind, anytime we're talking about things like wind, Okay, we say which direction it's going from. So this is north, east, south, west. So if it's flowing from the west, it's starting here, and we're just starting it at 0, 0 for now. And it's going from the west, which means toward the east. Its magnitude is 4. Okay, its velocity is 4. It is also the length of the segment from here to wherever we've stopped it at. So our wind coordinates are 4, 0. And its magnitude is 4. So now I want to find the actual speed of the bird. Sorry about that. All right, so what is the speed of the bird in miles per hour? So the first thing I need to do is I need to find my vector. So to find my vector, I'm going to take my 2 coordinates, okay, and I'm going to subtract them. So I'm going to have 4 minus 0 is my x minus my x. Okay, and I'm going to do my 8. Okay, so 0 minus 8. Okay, and that's going to give me 4 negative 8. So now from there, I have my vector. So from there, I can go ahead and find my magnitude. Okay, now keep in mind that when you do this, this is actually x2 minus x1 and y2 minus y1. So you don't have to replug it into the distance formula. So it's really just going to be 4 squared plus 8 squared, which is 64, plus 16, which is the square root of 80, which is approximately 8.94. Okay. So my bird is going in this direction with the wind, and so the wind is playing what kind of what is the wind helping it? Is it hindering it? And you do a lot with this when you're talking about airplanes and stuff. When you've got a tailwind and the wind is pushing the airplane and helping it fly faster, or when you've got a headwind and your airplane might be 15, 20 minutes late because you're slowing down because of wind velocity. Okay. All right, so really that was just kind of an example to get you started. Let's get into the real meat and bones of this. So this one says, let U be represented by the directed line segment P. So it's going to be from 0, 0 to 3, 2. Okay, so in other words, it's going from P to Q. And it says, and let V be represented. So this was, and let V, so this one was U. That's what I was looking for. And let V be represented by the directed line segment 1, 2 to S, which is 4, 4. So this is vector V. Okay, so vectors U and V. Okay. We want to show that U equals V. Okay. So remember, in order for directed line segments to be equivalent, they have to have the same direction and the same magnitude or length. Okay. So the first thing I'm going to do is I'm going to find their magnitude. In order to do that, I have to find the direction vector first. Okay, so I'm going to take my Q, my X on my Q minus my X on my P. So 3 minus 0 and 2 minus 0. So X2 minus X1, Y2 minus Y1. And I get 3, 2. So now for my magnitude, and really I didn't have to do that, but most of the time we're going to be finding those direction vectors anyways. Okay, so now I'm going to say, well, 3 squared plus 2 squared. Remember, these values are already our x2 minus our x1 and our y2 minus our y1. Okay, so that gives me 9 plus 4, and it's the square root. So it's the square root of 13. I don't really care what the square root of 13 is. I just need to now show that RS is also the square root of 13. Okay, so let's go ahead and find our vector for that. So we're going to take our S minus our R. So 4 minus 1 and 4 minus 2, which gives me 3, 2. Well, you notice that these are both the same thing. Okay, so 3, 2. Okay. So what that means is if I were to start both of these at 0, 0, okay, I would wind up at the point 3, 2 for both of them. So if I plug this in, well, it's the exact same. So it's going to be the square root of 9 plus 4, which is the square root of 13. So now we know that our magnitude is the same. Okay, so now we need to find our directions and we need to prove that the slopes are the same. Okay, so yes, we could count them. Okay, yes, we know that they're both 3, 2, and we're going to go on ahead and use the slope formula. Okay, so that's going to be y2 minus y1. Oh, look, we already did it right there over x2 minus x1. We already did it right there. Okay, same thing for rs. y2 minus y1, we already did it. x2 minus x1. And that's another reason, that I like to always put these in vector form, because then I already have all the information I need to finish, problems like this out. Okay. So now we've proven that these are equivalent vectors because they have the same length and they're going in the same direction because their slope is the same. Component form of a vector. So that's actually, what we have been doing. So component form of a vector. So it says a common vector is in standard position whose initial point is the origin. By doing so, the vector can be uniquely represented by the coordinates of its terminal point. So its terminal point. This is the component form of a vector, and we say rectangular form because we will be working with something called polar coordinates, okay, a little bit later. So the rectangular form of a vector is just written the way we just have done it. Okay. So if both the initial point and the terminal point are 0, 0, then V is called a zero vector, and it's denoted by 0 equals, and it's just going to be 0, 0 because that is its end point. Okay, so once again, the component form of the vector, just like we did on that previous problem, we're going to take our x's and subtract them. We're going to take our y's and subtract them. And it's always the terminal point. Okay, so here's our terminal point, okay, minus our initial. So last point minus our starting point. Okay, so you have to pay really close attention. So PQ, written as array, the last letter is my end point. Okay, so that's my terminal point. It doesn't matter in my problem which point I give you first, it matters how it's written here. If I write this as QP, then that means P is my terminal point. And so I better be doing P first here. Okay. And then the magnitude or length, once again, is just these squared and add it together and take the square root of them. Okay, so it's still the distance formula, we're just taking some steps out. Okay. If the magnitude of V is 1, then V is called a unit vector, and we're actually going to learn how to do that in the next section. And it says moreover, so plus, if the magnitude of V equals 0, then it's a 0 vector. Okay. So I know lots of information here. Once you start working problems, I think it's going to come together a little bit easier. So two vectors, U and V, are equal if and only if, okay, their vector component forms are the same. Okay. So back here where we did this, remember I said, oh, look, these are equivalent. So yes, we had to walk through and we actually showed it, but just by finding those two things, it tells us they're equivalent. So let's go on ahead. We're gonna, so I forgot to do a couple of things right here. So one is going to be the angle measure, so direction angle. Okay. So the direction angle is from 0 and it's counterclockwise. So it's like you're going around the unit circle. Okay, so that's like our unit circle. So there's two things we're going to find. So we're going to need to be able to find direction angles. Okay, so that's starting from 0. Okay, so that's starting from here and going this way. Okay, to wherever that vector ends, okay, or whichever way that vector is pointing. The other one is going to be the bearing. Okay, our bearing is from north, so it's starting here and it goes around however far we need to go. Okay, so it starts at north and goes clockwise. Okay, so two very important things because you guys are going to need to be finding that. And in real life, you have to find some of this stuff too. Okay. All right, so it says find the component form and length of the vector V that has initial point 3, -7 and terminal point -2, 5. Okay, so the very first thing I'm going to do here is I'm going to find my vector. So I'm going to take my, terminal point. So this, I'm going to take this value minus my initial, and I'm going to take my y of my terminal point minus my initial. Okay, so that gives me negative 5, 12. All right, so now once I have that, I can find the magnitude. So remember the magnitude, I've already done my x2 minus x1 and my y2 minus y1. So I'm going to do, I don't ever use a negative. Remember, if you're plugging this into your calculator and you're squaring it, it has to be inside parentheses. Otherwise, it's going to give you a negative number. But we know that when we square a negative number, we get a positive. So just keep that in mind. Okay? So negative 5 squared plus 12 squared equals 25 plus 144, which is the square root of 169, which is just 13. But I'm also going to have you guys find the bearing and the direction angle. So let's start with the direction angle. So I'm going to come over here and draw my picture. Okay, so my direction angle. So the very first thing I'm going to do is I'm going to draw this vector from 0, 0, because that's what we do. Okay, when we find the component form, that means we started at 0, 0. Okay, and we're going in the direction of negative 5. So our x is negative 5. And our y is up 12. Now we know that the magnitude or the length of this is 13. So that's my hypotenuse right here. So I now have a right triangle. Let's see, I'm going to move this negative 5 down there. I now have a right triangle in quadrant 2 of my unit circle or of my coordinate plane. And now I need to find the angle. So I need to find this angle right here so that I can figure out then what my direction angle here is. So I'm going to find theta eventually. Okay, so I'm just going to solve for x. Okay, well, I know that it's a right triangle, so I can use tangent of x equals opposite, so 12 over negative 5. It doesn't matter if you get a negative angle measure. Remember, we're talking about a reference angle here. Okay. So I'm just going to plug that into my calculator. So second tangent, 12 divided by, I'm going to go ahead and put negative 5. So I get negative 67.3 degrees. So x equals 67.3 degrees. But remember, I want to find this angle. So now I need to do 180 minus that 67.3. Okay. And we'll just round it to 67. Okay. And that gives me about 113 degrees. Okay. So that was my direction angle. Now for my bearing. Okay. So for my bearing, I know that this is 67 degrees. Okay. So I need to find from here all the way around to there. So I can do two different things. I can figure out this angle and do 360 minus this. Okay. Or if I know that from here to here is 180, okay, 270, I can take 270 and add 67. Usually most people do 360 minus something. So I'm going to find out what that missing angle is first, because this is a right angle right here. So 90 minus 67 gives me 23. So this is 23 degrees. And now if I do 360 minus 23 degrees, that gives me 337 degrees. Okay, so that's my actual bearing. So on your first worksheet, you're going to have some problems where you have to find just parts of this, some problems where you have to find all of this. All right, so definition of vector addition and scalar multiplication. Okay, so vector addition. When we have vector addition and we're adding two different vectors together, we just add the x components and we add the y components. That's it. It's scalar multiplication, vertical and horizontal stretches. Okay? Except it happens to both parts. So it's going to happen to the x and the y. So it's a dilation. If I talk about the opposite direction of a vector or the opposite of or the negative of, okay, that means that I'm just changing the sign of both the x and the y. Okay, so and the reason is, let's see, we'll just put one right here. So we'll call this 2 and our y value 3. So the opposite would be, so this is u, so negative u would be down here. Okay, and so this would be -2, and this would be -3. Okay, so we just changed the sign, changed the signs. And then the difference between u and v is just subtracting them. So let's take a look at how this works. So if I have vector addition, okay, so I'm going to draw two vectors here. So here's my vector v. Here's my vector u. If I draw vector u added onto this and vector v added onto this, then I'm going to get this diagonal right here. Okay. So vector addition is going to give me the total length of that vector, okay, which is this diagonal. So this would be u plus v. Okay. The parallelogram law is why this vector addition and vector subtraction works. And all that the parallelogram law says is that in a parallelogram with 4 sides and 2 diagonals, and we'll call these E and F, that if I take the sides squared and add them together, it gives me the lengths of the diagonals squared added together. Okay, that's the only thing. Okay, so now we're just taking half of it. So we're taking from here and here, okay, which means we're only going to get one diagonal squared instead of both. Okay, so that's why this works. Let's go on ahead and look at a picture for vector subtraction. So vector subtraction, we're going to essentially add the negative vector. So here is vector v. Here is vector u. So vector u negative is this. So I'm going to take the tip, okay, of 1 and I'm going to add negative u to it. Okay, so this is negative u. So now my new vector would be here. So that's all I did. Okay, so same thing. Now I'm just finding a new vector in the direction of v minus u. And the pictures, you know, they explain it a little bit. It's once you get to doing it, it actually seems a lot easier. So let's go on ahead and do a couple of these. So 2v. So all I'm going to do is I'm going to take my vector v and I'm going to multiply it by 2. So 2 times -2 and 5. So I have to distribute that 2. Okay, so it's a dilation, so I distribute it to both. And I'm going to get -4, 10. And that's it. That's my answer for 2v. Okay, w minus v. I'm going to show you 2 ways to do this. So way number 1, okay, I'm going to multiply by -1 for the v. So v is going to be multiplied by -1, which means that's going to be a -2 and a 5. That means it's going to be 2 and 5. Then I'm going to add them together because remember that w minus v is the same thing as w plus -v. Okay, so now I found -v. So now I'm going to do 3 plus 2, okay, and 4 plus 5. Okay, oh, minus 5. So that's going to give me 5 and -1. Okay, sorry about that. Let's go ahead and finish this up. So that's one way we could do it. The other way would just be to go on ahead and multiply by 1 or just subtract them. So you would just have to make sure that when you're subtracting them, that you do your w minus your -2, and then your 4 minus your 5. And in this case, it's not such a big deal, but you know, if you have like w minus 3v, okay, then you have to remember that if you multiply by a -3, then you've already distributed that negative sign to each of these components. Okay, so then you're really just adding. Okay, so either do multiply by a positive and then subtract the 2, or multiply by a negative, okay, and add the 2. Okay, don't do both. So now let's go on ahead and do v plus 2w. So I'm going to find 2w first. Okay, so that's 2 times 3, 4. Okay, and that gives me 6, 8. So now I'm going to do -2 plus 6 and 5 plus 8, which gives me 413. So my final answer. So that is it for the first part of 5.3. On your worksheet, problem number, well, if you're in person, on your worksheet, problem number 13, do A, B, and C, and we will do D and E together. Okay, so try A, B, and C, and we will do D and E together. All right, have a great day, and I'll talk to you guys all next time.